Hi, welcome. Today we're going to have a look at forces in equilibrium. So far we've been looking at forces that cause acceleration. So if I've got an object here and I apply a force, say in that direction there of 5 newtons, and let's make this let's say 15 kilogram object, then if it's on a frictionless surface, then we know that the force will cause acceleration by F equals ma, and that means 5 equals 15 times A would equal 1/3 or 0.3 meters per second squared. So this is an example of an unbalanced force causing acceleration. Today, however, we're going to have a look at forces that are in equilibrium. So here we are, we've got an object, and equilibrium means the forces on the object do not cause acceleration. In other words, they are balanced. So if that is let's go again, 15 kilogram force, and this is a 5 Newton force here, then we need a second force in the exact opposite direction to balance that force. And that means the sum of those forces is equal to 0. That symbol there is the sigma, and that means the sum of forces. Okay, or the sum of whatever this is, in this case it is the force. And that means it's not going to cause acceleration in the horizontal direction. If we also want no acceleration in the vertical direction, any force which is up here, so to say a 2 Newton there, would have to be balanced by a 2 Newton there. So all the forces in both directions must sum to 0. So what does the word equilibrium therefore mean? Equilibrium means that the forces are balanced, firstly, balanced, not balanced. They're all balanced and cause 0 or no acceleration. Okay. If they cause no acceleration, that means this object will not get faster, not get slower, and not change direction. So if it was already stationary, if it was stationary to begin with, it will remain stationary. If it was moving to begin with, it will remain moving. So it remains both of these. Just because a force is in equilibrium of an object means it's not going to stop the object from moving. If the object was already moving, it remains moving, but it does not get any faster. It's a constant velocity. Okay. And stationary is just a special version of a constant velocity equaling 0. Okay. So if you want to just, we'll stop this video here. You'll have a few moments of reading some textbook stuff, and then you're going to come back and we'll continue on doing forces in equilibrium. So go off to the textbook for the rest of this information.